Hey, welcome back, Marauders. This is section 4.1, Aqueous Solutions. Aqueous solutions are solutions where water is the solvent. So water is really good at dissolving things. A lot of things can be dissolved in water, so it's sometimes called the universal solvent because it is so good at dissolving things. We want to find out why water is so good at dissolving things. We're going to look at its structure. So if we draw a water molecule, it looks like this. And so usually when we draw a water molecule, we draw it in this shape right here. Where they're not in a straight line. It's not 180 degrees between the two hydrogens, but around 104.5 degrees between the two hydrogens. It makes this shape right here. And so water is a polar molecule, and what that means is that this bond right here, where the oxygen and the hydrogen are sharing electrons, they don't share the electrons evenly. The oxygen has what's called a higher electronegativity, meaning it pulls the electrons closer to itself. So the oxygen ends up with a partial negative charge, and the hydrogens end up with partial positive charges. So you have a polar molecule, meaning that it has a negative side and a positive side, slightly negative and slightly positive on each side of the water molecule. So it's really important to know kind of the shape of the water molecule, to know that the oxygen side is the side with the partial negative charge. It has a little bit more electron density close to it. And then the hydrogen side is the side with the little bit of a positive charge because the hydrogen has a little bit of less of the electrons close to it. So because water is polar, it's really good at dissolving things, especially ionic compounds. So here's a picture of some kind of salt. We can imagine it being sodium chloride. So in sodium chloride, you have sodium ions with a plus charge and chloride ions with a negative charge. And they're all stuck together. And so this is representing a big block of salt, a big chunk of salt. This pattern just repeats: sodium and chloride, sodium, chloride, and it's all stuck together like that. And then when it dissolves in water, what happens is that the water breaks it apart one piece at a time. So the water comes over and it picks apart the salt one ion at a time. And so you'll have a water molecule with the oxygen and the two hydrogens. And since the oxygen's a little bit negative, it's going to interact with the sodium. So you'll have an attraction between the oxygen, which is slightly negative charge, and the sodium ion, which has a positive charge. And so the sodium ions will all be surrounded by water molecules looking kind of like this, with the oxygen sides pointed in towards the sodium. And then the chloride ions will get pulled apart one ion at a time, and the chloride ions will be surrounded by the hydrogen side of the water molecule, because the hydrogen side is the side with the partial positive charge. And we know that opposite charges attract each other. So hydrogens have a little bit of a positive charge, and they're all going to be attracted to and surrounded by, or surrounding, the chloride ions. And so as the solid piece of salt, like this is a crystal of salt, gets dissolved, it gets pulled apart into ions. And so this solution over here is what we call an electrolyte solution because it contains ions. When a solution contains ions, these ions are now free to move around, and they can now conduct electricity, because electricity is moving charges, and now we have these ions which have a charge and are able to free to move around. So a solid piece of salt would not conduct electricity, but salt that's been dissolved in water does conduct electricity because the ions are free to move around. A couple terms that you'll see in this section: you'll see things that are strong electrolytes like sodium chloride. So if you have a chunk of salt, a crystal of salt, when it dissolves, it breaks apart into sodium ions and chloride ions. Sodium ions and chloride ions. And so all these particles are independent of each other and free to move around throughout the solution. Sodium and chloride. They're all free to move around, and it'll conduct electricity very well because it has all these positive and negatively charged, independently moving around pieces. Okay? A weak electrolyte would be something like HF. So if we dissolve HF in water, some of the particles break apart into hydrogen ions and fluoride ions, but the majority of the particles actually stay together as HF. HF, HF. So it still mixes into the water, but the majority of the pieces, like 99% of them, stay together as these molecules HF, and just a small percentage, like 1%, will actually form ions. So there's a few ions in this HF solution, but not nearly as many as there would be in a sodium chloride solution. The sodium chloride, 100% of them break apart into separate positive and negative ions. In a weak electrolyte solution, like hydrofluoric acid, HF, only a small percentage break apart into ions, and the majority still dissolve in the water. They still get mixed in, but they stay together as HF. And then a non-electrolyte would be something like C6H12O6. This doesn't break apart at all. This molecule stays together. So this is a sugar, and it can dissolve in water, but when it dissolves in water, it still stays as C6H12O6. And so that's like one molecule that stays together and gets surrounded by water molecules and is free to move around. This is not going to conduct electricity at all because it doesn't contain any ions. None of the carbons, hydrogens, or oxygens break apart and form ions. They just stay together in these neutral particles, these neutral molecules. So this will not conduct electricity at all. Okay, so strong electrolyte breaks apart completely into ions. Lots of ions means it's going to conduct electricity very well. A weak electrolyte means that a few of the pieces break apart, so it conducts a bit of electricity because it has a few ions in it. And then a non-electrolyte stays together completely as molecules, doesn't have any ions in the solution, so it will not conduct electricity at all.